Okay, so program evolution dynamics is a certain study of processes of system change, and this study was led by Lehman and Belady, where they propose what they call laws, and actually they are observations rather than laws, but these observations can be applied almost to all systems that they evolve. So the most important things that resulted from their study is, because they have a number of rules, as what they call laws, okay, but the conclusion out of it is system or change is inevitable, and then system requirements are likely to change because of the environment is changing. Means the surrounding or the environment where the system is being used is changing, so the requirements would evolve and change. So the delivered system won't meet its requirements, and then the requirements change and so on. So that's the source of one of the sources of changes. Systems are tightly coupled with their environments, and this means they are really attached with the environment. When a system is installed in an environment and it changes that environment, and the environment, or when the environment changed, then the system has to change to adapt or maintain the relationship between the relationship with the environment. So this is, for example, softwares that used to work on, let's say, Windows 7, and then Windows 8 come up. It has to adapt with Windows 8 in order to remain useful. And systems must be changed if they are to remain useful in the environment. Software maintenance is a term where it means modifying a program after it has been put into use. This term is mostly used for changing custom softwares, and we refer to custom software means a software that has been developed for a certain purpose for a certain organization. Generic software, however, they don't call it software maintenance, they create or they evolve to create new versions. And this is, for example, like Windows operating system, or all sort of servers like web servers and database servers, all applications that are that have generic purposes and used by lots of people. So maintenance does not normally involve major changes. It has, especially to the system architecture, it has minor changes. And these changes are implemented by modifying the existing components and adding new components. So it might be modification or addition. Maintenance has three different categories. Maintenance to repair software faults, where if there is any, and maintenance to adapt software to different operating environment, and that's if there is any changes to the environment running the system, and maintenance to add or modify functionalities. And this diagram illustrates the percentage of each of those categories in based on one of the studies. And you can see the maintenance based on functionality addition and modification is almost 2/3, while fault repair and environmental adaptation maintenance forms 1/3 of all maintenance activities. Maintenance cost is actually, it is costly, and it might be between 2 times to 100 times of the development cost. It is because affected by both technical and non-technical factors, and it increases as software is maintained. Means the more we maintain a software, the more the maintenance cost increase at the next stage, as maintenance corrupts software structure or affect software structure and makes further maintenance more difficult. Aging softwares can have high support cost, such as because they use old languages, so expertise in that language become difficult, and so on. So the cost or maintenance cost has several factors. Team stability. So if the team is stable or the same staff are doing the maintenance, the cost is reduced. Contractual responsibility. This means if the staff or the developers by contract are responsible of the maintenance with no incentive to design for future change, this means or this would bring the cost lower. Staff skills. Maintenance staff normally are inexperienced and have limited domain knowledge. This makes the maintenance more expensive. And program age and structure. And as program age, the structure is degraded and it becomes harder to understand and change, making the maintenance cost increase as the program age. Then maintenance should be predicted, and the prediction is concerned with assessing which part of the system may cause problems and have high maintenance cost, especially for business change. We can predict based on the business environment and business change what changes we should or what maintenance should take place on the system we are using. And change acceptance depends on maintainability of the components affected by the change, and implementing change degrades the system and reduces its maintainability. So maintenance cost depends on the number of changes that we have previously made to the system, and the cost of change depends on maintainability. So they are interrelated concepts: maintenance and maintainability. Maintenance cost depends on number of changes, and the more changes we have, the higher the cost. And then the cost of change depends on maintainability, means the less maintainable the system, the higher the cost. This diagram illustrates the maintenance prediction. So you can see predicting maintainability is concerned of what parts of the system will be the most expensive to maintain. And we have predicting system changes, what parts of the system are most likely to be affected by change requests and how many change requests can be expected. And then predicting maintenance cost, what would be the lifetime maintenance cost of this system and what will be the cost of maintenance maintaining the system over the next period of time, such as the next year. So these questions, answering these questions help to predict maintenance. Change prediction is predicting the number of change requires and understanding the relationships between system and environment. Now, tightly coupled system requires change whenever the environment is changed. And take, for example, a system that is related to government tax. So any modification announced by the government regarding the tax has to be reflected into these systems to be relevant or to remain relevant. So these kind of systems are tightly coupled systems because they are related to something important to everyone, to organizations. And factors influencing the relationship are, for example, number of complexity of system interfaces, the number of inherently volatile system requirements, and this means the number of requirements that are volatile or easily affected by change, and then the business processes where the system is used. Now, to measure the complexity of a system, we have complexity metrics which help us in assessing the complexity of a system components. Certain studies have shown that most maintenance efforts is spent on relatively small number of components in the system, and components depends on complexity of control structures, of data structures, and objects or methods. So these are three different levels of complexity. The most granular is objects and methods, how complex, how many functionalities inside those objects, and the method or procedure size is relevant, or it has to be a medium size, not very small, granular, not very big. Complexity of data structure. Are we collecting a lot of data in small data records or vice versa? And control structures. So that was complexity metrics. Process metrics can be used to assess maintainability, such as number of requests for corrective maintenance, average time required for impact analysis, average time taken to implement a change request, and number of outstanding change requests. I think you may have noticed that all these values are available or can be calculated based on previous maintenance phases. Means we need to do the maintenance at least once in order to know or to answer the numbers, or answer the factors here. So if any of all these is increasing, this indicates a decline in the maintainability of the system. So every round of maintenance on the system, we should collect those factors and compare them with previous maintenance round. And if those numbers are increasing, means the maintainability of the system is decreasing or declining. System re-engineering or restructuring is a process where could apply to a part of or all of a legacy system without changing its functionality. So it is applicable where this part of or all of the system requires frequent maintenance, and frequent maintenance means higher cost and higher effort. So re-engineering means rewriting or restructuring is a solution to reduce that cost, and re-engineering involves adding effort to make it easier to maintain. as the system may be restructured and redocumented.